Welcome to the Human 5.0 Project, the podcast where we cut straight to the breakthroughs that matter, the show where science meets self-optimization. I'm your host, Ultimate Biohacker 10X, and here we break down the real research, real data, and real dosing behind modern biohacking, from compounds and peptides to techniques, devices, lifestyle strategies, and performance protocols. Most people jump in and jump out before they get the gold, so we're keeping it tight and delivering the essential insights you need without the fluff. If you've taken the time to hit play, we'll make sure you walk away with valuable knowledge that can transform your approach to longevity, health optimization, and beyond. What's up, team? Welcome to a quick 5-minute Creatine for Dummies drop. This is Ultimate Biohacker 10X on the Human 5.0 Project, and today we're breaking down the single most researched supplement that upgrades your energy game without the hype. Today I dropped the masterclass, now the simple version. If you've ever wondered, why do I crash mid-set? How does creatine really work? This is it. We'll cover what creatine is, the ATP-Phosphocreatine reaction, the real mechanism, why it matters, and how to use it. Quick disclaimer, this is for educational purposes only, so talk to your clinician before starting, especially with kidney history. All right, let's lock it up. Creatine is a natural compound your body makes from amino acids, arginine, glycine, and methionine. Most, about 95%, lives in muscles as phosphocreatine, or PCR. Think of it as your rapid recharge battery. Your body makes about a gram a day, gets a gram from food, red meat, fish. They're the best. Plants have pretty much none. But high performers, we burn through it fast. Supplementing saturates stores for a bigger buffer. So here's the core. The reversible reaction that makes creatine a game changer. Creatine plus ATP becomes phosphocreatine, or PCr, plus ADP plus hydrogen. And this reaction goes in both directions, seamlessly, by creatine kinase, the enzyme. So what's happening mechanistically? ATP donates its phosphate, or the high-energy terminal phosphate. Creatine accepts that phosphate on its guanidino group. Result, phosphocreatine, a high-energy phosphate reservoir, waiting to be used. Why does it matter? Well, ATP levels are limited. So phosphocreatine stores energy without increasing osmotic stress on the body. So think of PCR as a rechargeable battery. It donates phosphate to ADP. This would be the energy release step. When does this happen? During high energy demand, like sprinting, lifting, jumping, any neural firing. So this reverse reaction of phosphocreatine plus ADP plus hydrogen equals creatine plus ATP is what you see under these circumstances. Key point here is that the reaction is near equilibrium. It really doesn't take much energy to go in either direction. It shifts instantly based on an ATP-ADP ratio. It's back and forth, no oxygen required, it's anaerobic, and it's immediate energy. So why is phosphocreatine high energy? Well, the phosphate bond in phosphocreatine has high phosphoryl transfer potential. It's slightly higher than ATP. So this allows rapid phosphate transfer to the ADP. Translation, phosphocreatine exists specifically to regenerate ATP faster than glycolysis or oxidative phosphorylation can. Think of it like this. Food, which is glucose and fats, gets shuttled to the mitochondria. That goes through the electron transport chain, which forms ATP. ATP charges the phosphocreatine. The phosphocreatine is sitting there waiting, and it can rapidly regenerate ATP when demand spikes by combining with ADP. No minerals are consumed, no energy is created. It's just time-shifting and location-shifting energy. Do you think it can be that easy? Well, it actually is. So what limits the system? Not phosphorus. The real bottlenecks are mitochondrial ATP production, oxygen delivery, and substrate availability. Creatine pool size. More creatine is a larger buffer. Creatine kinase activity, that's the enzyme that runs the reaction in both directions. It's an isoform expression, and it's sensitive to pH. So remember that. And then magnesium. ATP is biologically active as magnesium ATP, so low magnesium can give you poor utilization. So if we can train the ATP phosphocreatine system, the enzyme expression adapts, and this is good. Best training signals: sprints, 10 to 30 seconds. Heavy compound lifts, 1 to 5 reps. Explosive work, jumps or throws. Sound familiar? This is HIIT with full recovery. However, long, slow endurance alone doesn't upregulate CK meaningfully. So you don't just want to be on a treadmill walking without doing something to really boost this level. Power training tells the cell we need faster ATP buffering. We also need to maintain intracellular pH because acid wipes out creatine kinase, because that is pH sensitive. So what inhibits creatine kinase? Excess hydrogen atoms, or acidosis, severe glycolytic overload without recovery. So what helps? Adequate recovery, buffering capacity, beta-alanine indirect via carnosine, proper breathing or CO2 handling, and not training chronically overreached. So let's wrap this. Avoid chronic creatine kinase suppressors, inflammation, excess alcohol, severe electrolyte imbalance, and prolonged starvation. So here's an important clarification because there is common confusion. High serum CK equals muscle damage marker. High intracellular CK activity equals performance advantage. You want the second, not the first. Okay, so here's the Ultimate Biohacker 10X protocol. Newbie, 3 to 5 grams a day of monohydrate, no load needed. Hard charger, 5 to 10 grams a day, split if you go over 5 grams. Use hot coffee for max absorption. Stack with magnesium. Consistency is better than perfection. Creatine isn't magic. It's your ATP buffer for when life demands spikes. So if this helped, share it. This is Ultimate Biohacker 10X signing off. Stay strong, stay consistent, stay optimized, and don't stay dumb. I'm out. Thanks for listening to the Human 5.0 Project. If you found value in today's episode, share it with someone who's ready to elevate their biology. Make sure to follow the show for weekly deep dives into peptides, protocols, devices, lifestyle strategies, and the science of high-performance longevity. Until next time, stay curious, stay optimized, and stay 10X.